What a morning. I don't know what's going on with the local system, but it's not working right. Everything is going crazy. Looks like we need a system rebuild on this side. It looks like everything is kind of doing its own thing. So Stream Deck is kind of messed up this morning. Can't get the images working right. Couldn't get off the launch screen. Glad I got a cup of illy coffee in a Dallas cup, because I'm going to need it today. It's one of those days where just not everything is working like it should. So thanks to folks that hung out and waited for the technical difficulties to get over with. I'm glad you did. Let's look at what's going on today. There's a lot in the news. I'm going to go back and forth. Apple has gone through and looked at their systems and determined they needed to launch a patch about 40 different things. Total of 44 different patches were released, covering everything from Catalina 10.15.5 as well as older versions like Mojave and High Sierra. So there's patches galore for your Apple products, Mac OS. Go out there, get your systems updated. It's one of those things you just got to do. It's health and hygiene. A lot of stuff going on in the news. I just picked these big stories out. I'm glad I didn't pick a ton of them because, man, roughness in the morning. I don't know if I'm getting buffered a lot by YouTube or what's happening over there. We'll see. The other thing I think is interesting in the news today is there's a group called Fin7. And Fin7 is a hacking group that's attacked a bunch of people, including Chipotle, or Chipotle as I like to say, Trump Hotels, Whole Foods, all kinds of other places. This organization has been responsible for $1 billion or more worth of damages and money they've made, illicit revenue. Let me go back. The group's they've made $1 billion worth of illicit revenue in their hacking schemes and techniques. A lot of their stuff, social engineering, remote desktop calls, spear phishing kind of stuff. Definitely a group that has been an impact on the network. The weird thing about this group is they're set up like an organization. They have administrators that take care of their systems. They have a recruiting campaign. They use full-on development techniques, including process tools like Jira to track and flag issues as they build them out. They run their stuff through virus check, like virus total tools to make sure that they can get them through. All kinds of stuff. Very, very organized organization, as you could imagine. So the person is a Ukrainian, the guy they grabbed, and they're looking at grabbing 3 other Ukrainian nationals, according to the Department of Justice. And last up today is ransomware is on the increase. Last year, if you know what ransomware is, we'll throw the link up above. We'll throw a link up above so you can look into ransomware, what ransomware is and what it does. But in the last year, ransomware has increased 14 times. So 14 times it's increased. It's gotten 14 times bigger in just the last year. The average ransomware price has gone from $6,000 to $84,000. Reiku and ReEvil are the biggest ransomware tools out there. It shows no sign of slowing down. So make sure you're keeping your systems updated, patched. Make sure you're telling your friends. Watch out for these things. Social engineering is still a huge issue we've got to deal with. Speaking of social engineering, again, all over the news this morning, COVID-19 social engineering exploits are all over the place. We see social engineering as the main way people are getting into systems now, and then using other techniques once they're in. Let's see if our Stream Deck is still non-functional this morning. So the other thing, today, National Hamburger Day, held on May 28th. Some things you need to know. World's largest burger on September 2nd, 2012. Black Bear Casino Restaurant in Minnesota cooked the largest burger, weighing in at 2,014 pounds, equivalent to 8,056 quarter pounders. National French Fry Day is another day, not today. It's not National Hot Dog Day either. No historical information on who created National Hamburger Day, but it is today. Today is National Hamburger Day. So that's that. Let's do the intro and we'll jump into the slide deck. Hopefully technology works a little better after that. See you, babes.
Lance says he's got you now.
Okay. All right. I guess we're not getting the slide deck this morning or the cutscene either. Again, part of our technical difficulties. Jumping scenes the old-fashioned way. Let's jump to. There we go. All right. Hopefully, this will get things back on track. Grab the scene screen out of here because where to go? All right. So I'm Jim with Cyber-Recon. Welcome to your daily dose of security news, security information, security education. Today we're going to jump into a topic that a lot of us are using today. VPNs are virtual private networks, how they work, what they're all about. As always, if you could, hit that like button, hit the bell to be notified when new content comes out, and subscribe if you would. That would be wonderful. Let's jump into the deck. So this is part of Domain 2, Technologies and Tools for your Security Plus preparation. This is part of domain subdomain 2.1, where we talk about the different networking components. And today's topic is virtual private networks, or VPNs, and what all encompass a VPN and how you can use it to your best advantage as the security person in your organization. Let's fix the top of that screen there so you don't have to see it. So here's what we're talking about today. What is a VPN? What's a VPN concentrator? What's the difference between remote access and site-to-site access when we're talking about VPNs? What is IPSec, and what does it encompass, the modes that it uses, like tunnel mode, transport mode? What about some of the protocols it uses, like AH and ESP? We'll look at split tunnel versus full tunnel, and then we'll look at TLS and how TLS is being used in your VPN. So VPN, or Virtual Private Network, is a logical network that's established at the network layer of the OSI model. The logical network typically provides authentication and data confidentiality services for some or a subset of a larger physical network. From your friends at NIST, giving you a good definition like that. The good thing we need to know, it's a virtual secure network that we place over another network, like the internet. The other thing we note there, it's the OSI network layer, so we know that's layer 3 of the OSI model. And then if we need to talk about a concentrator is just that device that enables the VPN communications. Today we'll talk about a concentrator as if it was a separate device. For example, a Cisco 3030 is a specific device that has a sole purpose of enabling VPN communications. Know that most routers and firewalls can also establish VPN tunnels. So it's important to know. We'll be talking about a specific concentrator This is a physical device, but know that a VPN concentrator can be part of another device like a firewall or a router as well. We can use those for VPN as well. So when we talk about IPSec or IP security or IPSec, again, layer 3, the network layer, provides authentication and encryption over IP networks. That's important. There's two modes, tunnel mode and transport mode. And there's 4 sub-protocols. AH, authentication header, encapsulated security payload, ESP, IP comp, and we're not going to talk about IP comp a lot this morning because it's not in the Security Plus body of knowledge, but know that IP payload compression is handled through IP comp. So IP compression is what that stands for. And IKE negotiates shared key or key exchange, which is that shared secret that both ends need to know to be able to decrypt the traffic. So one end uses the same key to encrypt the traffic that the other end is going to use to decrypt the traffic. So we're using a shared key, a shared key between this session, right? So IKE handles that. So it's weird that Security Plus doesn't talk much about IP comp or IKE at this point, but that we will cover AH and ESP. Those are important to know when we talk about that. So that's some of the things that you need to know. So in the 2 modes of using a VPN, there's tunnel mode and there's transport mode. So in transport mode, only the data is protected, and in tunnel mode, both the data and the IP header are protected. So I like to think of this as if your data is going through a tunnel, you really can't see anything. You can't see the data because it's encrypted. You can't see the header because that's encrypted as well. So you don't know where the traffic's going to or where the traffic is coming from, essentially. But then in transport mode, I think of this as your data's on the back of a truck. It's covered up by a tarp. You can't see what the data is, but you do see information about the header. So maybe you see where the truck's coming from, maybe the license plate, maybe the name of the truck, maybe what is logoed on the truck. So remember, good thing to know, you just got to know these 2 things. The tunnel mode, the data and the IP header are protected, and in transport mode we only protect the data, right? We use protection on the data alone. And when we talk about protection here, we're talking about the encryption of that data. So next we talk about is AH versus ESP, and these two protocols we're going to use to protect our data, or encrypt it, or provide validation that it hasn't changed, right? So AH is the authentication header. That's what it stands for. It provides authentication of generally the entire data packet. It provides integrity. So when we're talking about our security triad, or security objectives of confidentiality, integrity, and availability, the AH provides integrity that the data has not changed in transit. It does this through a checksum or a hash of the specific fields, and we'll talk about that a little bit in a future slide and in this deck. But it provides proof that information hasn't changed as it's went across the internet. ESP, or encapsulating security payload, provides only encryption. So this provides confidentiality. We talk about our security triad. This is the encryption of the data, or depending on which mode we're in, the encryption of the data and the IP header. Uses symmetric logarithm, so it means it's a shared key. The sending unit and the receiving unit both use the same. For maximum protection, we want to use both AH and ESP. That way we have the integrity of the data and we have the confidentiality of the data as well, right? So it's important to know when we set up a VPN, are we doing it for remote access or are we doing it for a site-to-site connection? So right now I think a lot of us, let me back up. what a concentrator looks like, and we talked about a concentrator earlier. This is an older concentrator. This is a Cisco 3030. It only handles VPN communications. And again, these functions can be built into a firewall. They can be built into a router. So this one specifically is just a concentrator. So if you want to know what a VPN concentrator looks like, that's the Cisco 3030. A little bit of an older device, but it is still a concentrator. So you see in our corporate office, we have a VPN concentrator sitting there. And in a home office, where a lot of people are working right now, we're working remote, a lot of people, we've got to have the ability to connect securely to our workstation, our work center, our organization. So normally the way we're going to do this is through a remote access VPN session. So we're going to set up a session between our house, our home computer, or our work computer we brought home, and that VPN concentrator. So normally this is done with a piece of software that runs on a laptop or a desktop and connects into that VPN concentrator. Normally these aren't running all the time. Normally they're set up when a user is working, and there's a couple different modes we can log in to the software. So the other way is if we have another site, another organizational location, and we want to connect these two all the time. They're going to be generally connected all the time. That's when we're going to have a site-to-site connection. And normally we're not going to have software doing this. Normally we'll have two hardware devices, a hardware device on each side. So in this case, we're using specific VPN concentrators. This could be firewalls on both sides. It could be routers on both sides that provide the VPN functionality. But the big thing is there's devices on both sides. Behind those devices, the end users don't have to establish a VPN connection. The VPN connection will be handled when it hits that concentrator, and then at the other end it's let loose onto the network again. So know that generally that's the two modes of VPN connectivity: remote access. I think a lot of us are familiar with remote access now. We're using different types of software to log into our corporate networks from home, from our computers, and it's generally a piece of software you've got to run on your computer to get you access to that VPN concentrator on the other side. So the other thing we need to know is what is the difference between split tunneling and a full tunnel. So first we talk about this remote user, this home user that wants to go to Google. So in a full tunnel, when the user connects to the VPN concentrator, that's the only thing they're connected to. They're no longer connected to their home network. Now they're connected to the network at work. So, for example, in this scenario where you've got a full tunnel, if you have a printer at your house and you're used to printing to that, when you connect your VPN to your organization and you're using a full tunnel, you will no longer be able to print to that printer because your computer will not see that printer anymore. You'll be on a different network. You're going to be on your corporate network. And if you want to go to some place like Google, whoops, the lines are all messed up. Through all these. All right, so we can't do this. I think my lines, everything is kind of off today. So in this situation, if I'm on a full tunnel and I want to go to Google to check something out, that traffic will route, use my mouse, so the traffic will route from your house to the VPN concentrator and then to Google, and then the reply will come back down to the VPN concentrator and back to your house. And this is important because if there are rules in place at your organization that prevent you from going to specific sites, there's say a web proxy in place. Those proxy rules will be in place. So if you try to go to some place from your VPN connector in full tunnel mode, then those rules will be applied. So if you try to go to a gambling site or something like that while you're logged into the VPN, you're going to get the warning. You may be blocked. You may be logged. You may get other actions taken. And I don't know, is my... Okay, there we go. Not sure what's happening there. So the difference is in a split tunnel, we establish one connection to the VPN concentrator at work, and specific network traffic is set to go to that network. But there's also a second network connection that's connected to your home network. And when you go to Google, you go through your home network. When you go to your work file share, you're going to go through the VPN connection. Now, this is less overhead on your organization because they're not going to have to route all that traffic to Google and back to them and then back out to you. The problem is that now that you've got two connections, you've got your one computer with a connection to your home network, to Google, and then you've got another connection to a VPN to your work network, where you're essentially sitting on your organizational local area network. You've created a bridge between your home network and the work network. And if you connect to something on your home network that maybe is a little bit malicious, it's going to have the ability to go through your computer and right to your organization. So a lot of the security protections that are in place at your organization can be bypassed if we allow split tunneling. So a lot of times if an organization has built their VPN structure correctly, they will not allow split tunneling. So when you connect to your VPN, that's the only thing you'll connect to. You'll be connected to your organization, and that's all. So one of the things a lot of organizations will do is also an always-on VPN. So in essence, as soon as you turn your computer on, there's going to be a connection to the VPN concentrator. So you're never going to have the ability to log on to another network. You're never going to have the ability to go, say, to a website without going through your organizational structure. In an always-on VPN, as soon as you start your computer, as soon as you get your network up and running, it's going to connect to the VPN. So in these cases, you're always going to be connected. The security protocols from your organization are always going to be in place. You're not going to really have the ability to turn on or off your VPN. If your computer's on and the network stack is built, you're going to be connected to the VPN. And that's the way these are structured. So always on, just like it sounds. It's always on. It's always up and running, right? So the other thing you should know is some organizations will use TLS, or Transport Layer Security, for their connection to the VPN. This uses a well-known port, 443, which is used for HTTPS, or Secure Hypertext Transfer Protocol messages, web traffic, secure web traffic. It's essentially a web-based VPN. It's essentially a web-based VPN and uses certificates for manual authentication. It replaces SSL. So if anybody's out there using an SSL VPN, that's bad. That's bad news. We shouldn't be using SSL for anything. There are far too many exploits for SSL, or secure socket layers. That should be gone everywhere. So if your organization has problems running what normal IPSec or normal VPN ports, like for example, Cisco likes to use 500 or 4500 or 10,000. If those ports can't be used, sometimes it's easier to use a TLS VPN session or a web-based VPN using a well-known port that's usually open on most networks, like 443. So, think about, we talked earlier about what AH does. So AH is the authentication header. This provides integrity that the data has not changed from when it was sent from the originator to when it was received at the destination. The way it does this is it takes the data and it adds the IP header, and then it adds the shared key. It runs that through a crypto hash, and it provides the authentication header. So if we know about hashing, we know that once we combine these data, the IP header, and the shared key, once we hash that, we're going to come up with the extremely complex mathematical function that ends up with a sequence of hexadecimal numbers, usually, that will indicate if any of that has changed. So in transit, if someone goes in and changes even a small amount of the data, a character, adds a character or adds malicious code, the hash changes, and it will indicate that data has changed in transit. So that's how the AH value works. That's how we ensure that the data has not changed. We do that with a crypto function along the way, and some of the crypto hashes they use are MD5. That's not MDS. It should be MD5, SHA-1 or SHA-2. And really, of these, you should be using SHA-2. The other two, MD5 and SHA-1, are fairly insecure nowadays. So we should be using SHA-2. We do that hashing function. What's going to happen is the data will transit the network. And remember, with AH, the data is not encrypted. So when it gets to the other end, the receiver is going to see the same data, the same IP header. They're going to have their copy of the shared key, and they're going to run that same SHA-2 value. It should equal the same result. So when we add the data and the IP header and the shared key, and we run it through SHA-2, it should result in the exact same value. If it doesn't result in the exact same value, then we know that the data has been changed in transit. That's the importance of the AH. So we know that ESP encrypts the data, and AH provides our authentication or integrity check. So in transport mode, this is what your data looks like. And it's good to know this reference. I'm not sure that you're going to need to know it for the Security Plus exam, but it's good to see this in as it lays out in a kind of a pseudo version of the IP packet that's going on. So normally we have our data. That's the thing we're trying to get to the other end, right? We're going to add that ESP header to it. We're going to have the AH header to it. And then we have our IP header. Remember, this is transport mode. So if you look here, we see our data is there, and our IP header is still the same, and it's leading the parade. It's getting us where we have to go, because that's what the IP header does. It provides that source and destination information. We also add an ESP trailer, and we add an integrity check to the back, right? So now we've got our packet. This is what it's going to look like. In transport mode, there's one more function we've got to do, and we've got to encrypt the data, right? So the trailer gets encrypted as well, and now it's encrypted, right? So now we have, this is the only portion of the packet that's encrypted, and we've done that by just scrambling the letters in this example. So this portion's encrypted, the rest of it is authenticated, right? So if we look in the tunnel mode, I'm not sure why the tunnel didn't come up, but we have our data there as well. In front of it is the IP header. In front of that is an ESP header. An AH header's in front of that. There's also a new IP address attached to the front so we know where we're going. There's an integrity check. And in this case, we have all of this information that's encrypted. And of course, the new IP header in the front provides our destination information. So that is the rundown on a weird day that doesn't seem to be. Seems to be gremlins are everywhere today. So hopefully that provides you a good overview of VPN, what you need to know for the Security Plus exam, what you need to know for the basics of being in security. So need to know what a VPN is, know what a VPN concentrator is, know the difference between remote access and site-to-site access, know the things about IPSec, know the difference between tunnel mode and transport mode, know what AH does and know what ESP does, know the difference between a split tunnel and a full tunnel, know what the always-on connection is, and know about TLS, why we use TLS and what it's all about. Glad you hung with me during the technical difficulties today. We're probably going to have to do some tune-ups and maintenance on the old Macintosh today to get it up and running. Maybe it's part of the patching we need to do. But as always, I'm Jim with Cyber-Recon. Hopefully you're having a good day. Be safe when you're out there. Hit the bell, like, comment, subscribe. Love to hear what you got to say. Wow. As always, be safe out there, and we'll see you next time.